Whoa! How are we going to solve this? We can't use substitution, and integration by parts just makes it look too complicated. What are we going to do? I have an idea. What if we use the trig identity that sine of alpha times sine of beta is equal to 1 over 2 of cosine of alpha minus beta minus cosine of alpha plus beta. How can we use this? Well, we see here that it's in the form of sine of alpha, where alpha is 2017x, and sine of 2018x, which is the equivalent of sine of beta, where beta is 2018x. So maybe we can use that identity to simplify this into an integral that we do know. So if we replace the inside with 1 over 2 of cosine alpha is 2017x, and beta is 2018x, minus cosine, and this time we're adding alpha and beta. We're adding 2017x plus 2018x. Close the bracket, dx. Whoa, this looks even more complicated. How are we going to go from here? But we can do many steps to simplify this. First, we can bring the 1 over 2 to the outside, since it's a constant. So we have 1 over 2 of the integral of cosine of, well, we can just simplify the inside. 2017x minus 2018x is just negative x, minus cosine 2017x plus 2018x is 4035x dx. We can simplify this further into two separate integrals. We have 1 over 2 of the integral of cosine of negative x dx minus 1 over 2 of the integral of cosine of 4035x dx. Because remember, we have to distribute the 1 over 2 to both the first integral and the second integral if we're going to add a sign there to break this up. So if we remember from the cosine graph, the cosine graph looks something like this. And you can see it's an even function, where the graph is just a reflection across the y-axis, where cosine of x equals cosine of negative x. So we can just substitute this in, where we use cosine of x equals cosine of negative x to make this much simpler. We just have the integral of cosine of x dx, which we know because the antiderivative of cosine of x is just 1 over 2 sine of x. And then for the second part, we can use u substitution to figure this out. We can set u to 4035x, and therefore du would be equal to 4035 du. But where are we going to get 4035 dx? Well, we have dx here, but we need to insert a 4035 inside the integral. And we can do that without changing the actual value of things by multiplying 4035 on the outside. So we have 1 over 2. We have 1 over 2. And let's just multiply this by 1 over 4035. And we can just resolve things inside by multiplying by 4035 times the cosine of 4035x dx. Now we have u and du. U can be found here, and du can be found here. So we can simplify this even further. We can drag this part, copy this down. So we have the integral of cosine of u du. And the antiderivative of cosine of u is, again, sine of u. So let's copy this one more time. And we have sine of u. And since we already know what u is, we can just substitute that in for this to become sine of 4035x. Now let's just simplify things even more just by multiplying things together. This is simple algebra. Sine of x over 2 minus sine of 4035x, give them brackets. And 2 times 4035 is just 8070, and we can't forget the plus c, and there we have it. Our final answer, the integral of sine of 2017x times sine of 2018x dx is just sine x over 2 minus sine of 4035x over 8070 plus c.